I have never done this anywhere where we set out to do a thing and it worked the first time, right? You learn a bunch of stuff along the way and you burn it down and you try again, right? Yep.
Yeah.
It's software.
But you get the benefit of saying, okay, it's just software, right? So that didn't work. Let's go tear it apart.
Hello, and welcome to another episode of Kumulus on Cloud. I'm Robert Starmer, and as usual, I'm joined by our fabulous co-host, Lew Tucker. Hi, Lew.
How do you do?
And today we're also joined by our fabulous guest, Mike Damkot. Mike, why don't you introduce yourself to the listeners?
Hey, guys. Well, thanks for having me. My name's Michael. I've been working in technology for 20 some odd years. Full disclosure, I've got a long background with Robert. We've known each other for a long time. I did work with these guys years ago, but I've worked at various size companies. I've worked in telecom. I've worked in the SaaS space for most of my career. And quite frankly, I got my start in this a long time ago when I first met Robert, when I was working on projects back when OpenStack was the hot new thing, and was working on automating networks way back then. And that's kind of where I got my start. So I appreciate being here, and I hope I can contribute some bits of knowledge to the conversation.
Sure. And today we're going to discuss, I'm sure you're ready for this. We're going to discuss cloud computing, but we're going to focus on really things that are driving some interesting cloud value. And most importantly, some of the areas that Mike has been really focused on in his previous couple of jobs, which is infrastructure as code, right? So not just what is cloud and what is cloud infrastructure, but really how do you actually handle and manage your infrastructure, defining it in a code-like fashion, right? So I guess maybe that's sort of the first question. And what the heck does that really mean, right? We all understand infrastructure. I think we get what infrastructure is, but what makes it codey? Or codified.
Well, I could start off. I think that what we've seen has been traditionally, we had system admins running around data centers, configuring networks, bringing up servers, and trying to write down how they did it, and so that you could do it again and again. And that has proved to be very error prone. And very hard to reproduce, and you then quite often don't even know what you've got. So this whole notion that really started years ago, where we talked about it as DevOps, as well as what we really need to do is apply some of the capabilities that we have in automation and software to replace these manual processes with those things that we can actually formally write as code. We can check it in, we can use repositories, we can update these things, and then we can have repeatable processes. And that's, I think, led to this whole notion of infrastructure as a code, which was happening around the same time as cloud computing. Obviously, on somebody else's infrastructure in cloud, that's the only way to do it. So I think that now proved to be very good, not only in the cloud, but also in your own data centers. So, Mike, I'm sure you would agree.
Yeah, I think about infrastructure as code as two foundationally different things that get you toward the same goal, right? One, you mentioned that, and this is how I got my start in my career, right? You run around, you configure things, you write down what you did, you write down what you figured out, you write a how-to document, and then hopefully somebody else didn't come along and change it, or, you don't miss the syslog message that says, hey, by the way, this configuration changed. But I think we learned, 20, 25 years ago, Lew, that ultimately you will end up with a deviation from the plan. Right? It is a foregone conclusion. It's just a matter of time. So you really get repeatability, right? You get repeatability at scale by writing infrastructure as code. And then the other thing, when I'm thinking about building systems, is I get front loading of work, right? So when we use that same model of engineers running around configuring things, making it all work, what we were really doing is an iterative process, right? I need more capacity, so somebody has to go touch it. And the time aspect associated with that and the time spent building that was N times an engineer times the number of nodes. When we get to declare to code, and when you couple that with deployment systems that allow you to do it at scale, you get a front loading of effort that allows you to build things faster, repeatably. I said that very poorly. You can build things in a repeatable manner at a much faster clip if you spend the time up front to declare and write down your infrastructure as code and then stamp it in over and over and over.
Well, I mean, I've built infrastructure as code back in the day before there were APIs to even talk to physical hardware. I mean, cloud completely changes the game because cloud is, in its pure nature, an API-driven infrastructure, right? All of the resources, whether it's the lowest level of metal-style infrastructure or moving up into software as a service or platform as a service type interfaces, we're talking about APIs. When you were working at, on physical devices and your way of scripting things was to effectively log in and run a script that would execute tasks, you had to build a bunch of additional infrastructure around making that viable and safe. Like you said, you missed the syslog message that said, you don't have interface 42 because that module died, right? Or what have you. With cloud infrastructure and with APIs, you suddenly have the flexibility of defining things via code via a specific API rather than a command line interface. It's just like how I think a lot of this sort of thing started. And we've all worked with tools, or at least I think we have worked with tools, not necessarily our listeners have worked with tools where, we were trying to emulate that. Things like Ansible, where you basically wrote a script that ran some commands for you. But those sorts of interfaces were a real problem. So with that sort of shift, now that we have APIs, is infrastructure as code really something that is only cloud specific, or are we seeing sort of a broader reach of this model, this mindset, and what's driving that infrastructure? Either of you.
Well, I'm going to jump on that one and say, I mean, I got my start in this dance, right, in this space by using tools like Puppet and Chef to impart configurations on switches, but I had to do it through a command line because there was no such thing as running a Chef module or a Chef unit on a switch. It wasn't a thing you could do. So what I did is ran Chef and hit the command line, right?
Yeah.
And I'll give a head tilt to a different podcast that's been around a long time. I think over a decade ago, I was talking about how we do this on the Packet Pushers podcast way back in the day when I was just starting to figure out how to use Chef and Ansible and Puppet to do these things. I think the investment is there, right? The desire is there. I think there's still a lot of opportunity for standardization, right? But I think the API-driven world over the last decade or more, really, has changed that mantra and made it much easier to do, right? The barrier to entry is much lower than it used to be because a lot of things come out of the box with the ability to take a programmatic input that we were lacking a while ago.
Yeah, I mean, I would say over the last the last 10 years, the network infrastructure, the compute infrastructure. I mean, if you look at what's happened with physical compute, even though, again, I think the big shift is towards cloud and managed cloud infrastructure and automating your cloud infrastructure because that's where the real benefits lie, right? I mean, otherwise, you're going right back to I've got data center managers and I can move them into the cloud, but they do the exact same thing and they still treat a virtual machine as if it were a physical machine in some cases. If I can get to that infrastructure mindset, I guess maybe that's really part of it, right? Lew, you mentioned that DevOps was sort of a driver to the infrastructure as code systems model and thinking. And DevOps is really developer centric. The idea is sort of the developer can handle the entire flow from I've got the idea for the app to I know how to run the app. So in a sense, what's the role of IT here? Does IT still have a place in this kind of, if I could migrate everything to it's all codified, it's infrastructure as code, it's stored in the source code repository, where does IT really fit in this infrastructure or this codified systems world?
You've probably seen it several different ways, right?
I have. So let me give you my holistic mantra, right? I've done this about 6 times now. Gone from let's do stuff, people running around, and this isn't even a technology problem, right? This is cultural and this is people based. And one of the first fears always is that my skill set is no longer needed. it's just not true, right? First off, a really good engineer that can troubleshoot a problem is still a really good engineer that can troubleshoot a problem. And you cannot codify in code break fix because it turns out things broke. They were not operating the way you expected, and you have to go figure it out. And secondly, every place I've worked, every team I've worked on to try to do this, we end up with as many or more people. It's just that the day-to-day work shifts, right? The number of tools, the frameworks you need to use, the systems you need to operate things at scale through declaration, it doesn't just happen. You can't just you could run a PowerShell script on your laptop and use that to manage your infrastructure, but you're quickly going to run into a scale problem, right? So we need pipelines, and we need, things like, code repos and all the things that we're really accustomed to when we're writing software. But we have to take that software-esque approach and impart it. And there is a skill set there. There's a talent there to manage those things at scale. And those are really modern infrastructure engineers, if you will, because those in and of themselves don't run themselves, and they're complex, and they need skill set to operate.
Yeah. So isn't it also true then that a lot of what we saw in trying to build very, very large scale software systems that had lots of different services and changes happening very, very rapidly, almost make applying that same principle to infrastructure a much simpler problem, because you can now look at infrastructure as something that can be programmed, and that with virtual machines going into cloud computing, and particularly now as we move to containers, where you can spin up and spin down a container in literally in seconds, that's a very different time scale than we had, which was like rolling in a new server, stacking and racking switches and everything else like that. So software alone is the only thing that can really manage at that speed. And it gives the developers and the people who are really trying to manage this infrastructure many, many more tools and much more powerful tools, being able to use software methodologies for checking in code, revisions, being able to roll something back. You'd be able to do that as software as infrastructure. It's very difficult to roll anything back if you're doing it by manual processes.
Yeah, it usually requires a VTY port and an RS-232 cable and a guy with a laptop in a place when a network config went bad.
That's right. That's right.
Yeah.
I mean, I think that's actually an interesting comment, though. Infrastructure as code works as long as you have connectivity. So does infrastructure as code apply to the physical data center as easily? I mean, do you have, I know that some of the newer switches, when I was still working with physical switches, some of the newer switches did have sort of fallback config, right? So you could say, I can write a config, and instead of it being immediately executed, I could execute it in sort of in memory. And worst case scenario, if I lost connectivity, Watchdog would kick off, the system would reboot and start with the previous config. So you could sort of get back to known good state. I guess in my mind, the question is infrastructure as code really something, I think I kind of asked this maybe a different way earlier, but is infrastructure as code really something that is primarily targeted at the cloud style layer of abstraction? I mean, Lew, we talked previously about the fact that there's nothing new in the software world, right? It's all just, let me add another abstraction layer on top, and with that abstraction layer, add more flexibility, right? Yep. So really, should we be looking at infrastructure as code? Again, we can codify physical resources. We know we have decent programming interfaces for networks and network services, because that's such an important piece. But if you lose that connectivity, how do you recover? And I'm not sure that level of infrastructure has really sort of kept up with some of the automation that you have. I mean, I can think of at least one case where I have managed to break something like Amazon, where they released a new service and I created something and then I couldn't delete it. I'm not sure. I think that resource may still be floating out there. Right?
As long as it's not showing up on your bill, right?
Yes, exactly. I think it was just like a placeholder thing. But yeah, I guess, when I asked earlier, it's like, is there a need for IT? I guess there is still always what's that absolute worst case break fix that I need. But in most cases, I think the benefit of infrastructure as code far outweighs the few potential corner cases where things could really blow up on you, I guess.
I think that's a design construct, right? That's a preparation and planning thing, right? I can give you an example from my days back in the day at a cable company, right? I was running a large test environment, and we needed to be able to modify the equipment in the rack. So I designed a model that we had. Wow, it's been a long time now. I can remember. I bought these custom like 6U modules that bolted 2 ladder racks, and I hung switches above the racks at the end of the row. And those switches were there just to facilitate connectivity to the console ports of all the rest of the network equipment in the environment.
Oh, yeah.
So we used automation to manage the physical infrastructure on a different network in a different environment so that if everything went badly, I could still,
that's a good point.
Back in the day, it was more script work, but it was biased back toward infrastructure as code to declare that I wanted to get things back to a working state.
Right.
Yeah.
Right. So I think in answer to your question also, Robert, is that once you have a physical system, a plant constructed, I mean, obviously we still use people and forklifts and things like that to bring in equipment. And you bring it up to a certain level of capability, at which point then if you're starting to put in things such as Kubernetes and other virtualized environments in that data center, that's your own data center, infrastructure as code is absolutely what you use now to manage that, just as you would in the cloud. So I think and Mike, it might also be good to hear about, do you see this as a cost advantage? Do you see this, you've said that you can do a lot of work up front first, but it seems like overall, what we're always trying to do is get more for the same resources that we have. We want, stacking up virtual machines. We want to be able to make our people much more effective and productive. Is that where the cost savings that come from?
Well, Lou, I'm going to give you a very leadership-esque answer, right? It depends. From a cost savings perspective, if you're talking about managing finances, right? If you're working with finance and talking about capital expenditure versus operationalizing costs, being able to go to a third party, i.e. a big cloud provider, or even one of the smaller ones, and imparting all of this in code gives me the ability to only run what I need. If we talk about it for managing a large scale infrastructure, the way these folks do, or smaller companies, then potentially, yes, right? It kind of depends on how you think about your costs and where you're prioritizing things. If you do this with the intent of cost savings, like, oh, this is just going to save me money, I think you're going to be sorely upset.
No.
Right?
Right.
But I think
doing more with the same.
Yes, exactly. Right. Where you get the benefit is when you get the repeatability, you have less of, you spend less time fixing the deviations and you spend more time up front declaring what you want through the systems, and you get more output from engineers that are developing the new things than you do fixing the things that are already running. So I think ultimately you get cost savings, but it's not a panacea, right? You have to put the work in to get the savings over time.
Exactly.
That was a very wishy-washy answer.
Well, I don't think it was wishy-washy. I think it's right. That there is effort in going to an infrastructure as code model, right? There's retraining, if nothing else, right? So people that are used to working in a certain fashion, they're not used to working with a source code repository of any nature, right? And especially one where in the past they're like, well, no, I had these commands in my head. I just went and typed them into a box. Right. It's like, well, yeah. And there's an API and you could have run a script and you could have run it with a script. And now suddenly it's like, I don't even want you to go to a console anymore. Right. I really want you to say, this is the configuration. This is the state I want. And the system will handle delivering your state, right? Define the state change. So on top of the effort needed to implement that kind of infrastructure, whether it's something like Terraform or an Ansible or whatever, pulling those modules together in the way that meets your business's requirements and security and all the other operational requirements that exist. There is the people part of it, which is taking those people that in the past did manage things by point and click into, let me define my system state through a set of configuration parameters. So it really does sort of change the game quite significantly.
I want to push back on one thing you said. And you're absolutely right, but I just want to call it out in the bigger context of the three graybeards here on the podcast talking about we've seen all the things for forever, right? The concept of retraining and the fear of retraining comes up a lot. right? It has been my experience that it's a barrier to entry quite a bit. But when I think about it holistically at the big scale, right? Like if I'm a developer in the middle or the second half of my career and I'm really good at writing COBOL, well, I hope I get a job at a bank because that's like the one place that's still using COBOL, right? Retraining is a perpetual thing. That's just career management. That's relearning tools. And what we're really talking about is just a progression in tools that allow us to be more efficient and faster at scale to get, as Lew said, like more bang for the same buck.
Yeah.
Retraining should not be a fear. And if anybody's listening and saying, oh man, this sounds really, really hard. Well, everything's hard when you start, but eventually the benefits outweigh the pain. You just have to take that first step and start the approach.
Well, I think of it another way as well. I mean, on the training side of things, I mean, Kumulus does a lot of training, so this is part of my space. But one of the things that we've often seen is that it's not so much about retraining, because it's not like you used to be shoveling coal into a steam engine and suddenly all you have to do is manage a throttle on a diesel engine or something like that, right? It really is. Maybe it is more along those lines. It's like, hey, I've taken a piece of the overhead away from you, and now instead of you having to go manually say, I want a virtual machine, you just say, there should be a virtual machine with this name and this IP address potentially. Make it so, right? It's like suddenly you just got a promotion. Now you're captain of your starship instead of just the engineer in the back, right?
Yep.
And yeah, there are ways of thinking about how you interact with the infrastructure, and I guess that's the retraining I was thinking about, was that you're really changing your mindset about what it means to have infrastructure, what it means to own resources. There's the horrible pets versus cattle.
Oh man, I haven't heard that one in a long time.
Yeah, and every time I say it, I'm like, why am I saying it? But there's no easy way of describing this, right? There's the thing that I own that I love versus the thing that I use, but I don't have the same connection to, that same mental and emotional connection to. And in a sense, it goes right back to that layers of abstraction, Lew, right? It's like, I've added a layer of abstraction on top of the infrastructure. I've defined it in a codified way so that I can keep track of it. I can write scripts so that I can replicate it easily. And yet I don't have to care about it as much. If something goes wrong, again, hey, the physical network, I fat fingered a config accidentally. I can just hit a button, revert to the previous state, right? And that mindset of all I have to do is revert and things will come back to at least a functional state. Maybe I didn't get the feature I tried to deploy, right? And I think it's that mindset retraining that is really the important part. The actual effort for somebody who's in the space is minor, because it should just be, well, instead of having to think about what's the command to turn an interface on a router, great, I don't have to think about that. I just need to know an interface. I need to know the interface name. So what's my list of interfaces? And with that, I can make all the connections happen.
Well, this is where I think the power of virtualized environments, containers, Kubernetes, when we get into things such as we've talked in a previous podcast about Istio and service meshes, we are increasing these levels of abstraction, as I like to say. But it's the analogy I think that I find very useful, because and I back to the retraining question and everything, I actually think most of the developers I've interacted with actually love to learn new things. They might resist because initially it's more work.
Yeah.
But once you get past that more work, like everything else, then your life becomes much, much easier and much more predictable, because if there's anything that we all abhor, whatever is unpredictable or not really knowing whether something's going to be up and running, and being able to do canary deployments and things like that, which you can easily do with software. I would hate to ask people physically to go and do something by setting up something manually, which means, and then shift over traffic. I want to be able to do that all in this kind of virtualized, containerized world. So that's where I think, and you get to talk much more, I think, declarative rather than procedural. Being able to say, this is the recipe I want. This is the dish I'm making tonight. It has these ingredients. They're done in, that's the thing that we want to be able to work towards, because then we have systems that can help us do that. And that's the only way I think that we can operate at scale.
Yeah, I mean, I think that the infrastructure as code question really comes down to how do you realign your teams currently, because to the point that if I'm going to change how my resources are being handled and how they're being discovered, again, if I get to that state-based configuration, that declarative model for the resource, the application, the system state, the API interface that's running that has all these pieces behind it, somebody still has to put together the model for your application build environment, right? So the developers that are building this, right, those DevOps guys that seem to have this all under their belt already, they maybe have a model, but I think we've all seen there are so many different ways to sort of handle this particular, approach this particular problem. Everybody has a slightly different opinion about which pieces you do in what way. And I think the one thing that infrastructure as code gives you the ability to do with the right programming experience and the right development behind it is define, this is our architectural platform for the business, right? If you want to build an application, you should hopefully be able to say, yes, let me go grab a templated resource or a templated model that includes, how do I get access to a container production environment, right? Is it a serverless or function as a service type thing? Is it Kubernetes? Is it a function as a service on Kubernetes, right? What is helping me make those things happen? As soon as I've defined that stack, now I can write the code around that stack of resources, whether it's, hey, I have to have a physical link because I'm, creating super secure links to people. I don't know what, there has to be that model of what is the infrastructure I'm using. And once I've defined that, hopefully in conjunction with at least the product managers and the developers that are supposed to build on top of this, so that I'm not missing some feature somewhere that has to be there. I can actually start really building this and defining the code that defines my declarative state. And now I can get to state-based infrastructure, state-based operations even, as a way of thinking about it.
What I just heard you say is, this is a really powerful tool, but it requires a little bit of pre-planning, because now you can shoot yourself in the foot at scale if it turns out you don't have a framework for people to operate within. Right. And I think that's been one of the biggest hurdles in places that have folks that have struggled with this. Right.
Yeah.
The velocity that you get out of declaring things is it's exponential. Right. But if everyone's declaring it differently, you're right back to the same problem of Bob's got to go in and touch the unique bespoke thing, because what you end up with is 15 bespoke ways to do declared state. And
right.
ultimately you end up fixing that thing. Right.
Yeah. Bob just left the company and nobody knows how to do what Bob did, even though it was codified. At least we can restart it.
Yeah.
I mean, yeah. No, that's a really good point.
Michael, in your experience, then how do you organize teams around this kind of concept? I mean, in the days you had application developers, you had sort of IT infrastructure staff, you had network engineering, you had security teams. How have you've done this several times now? What's worked for you?
Well, I don't want to say I have a playbook, Lew, but I kind of have a playbook. First off, you have to get comfortable with the fact that the world's going to work differently, right? And this is before we ever touch technology, right? Hey, look, you kind of have to sell the fact that the benefits are great, but we're going to put some work into it. You still need, like, using the I'll call it legacy model, right? The network experts and the security experts and the software development experts. You need all of those people still. You need that knowledge base. You need that foundation, right? I really like putting them together in cross-functional teams and then figuring out a roadmap, right? Okay, if I'm going to declare all of my networks, here are the underlying tools I need to do it. And if I'm going to declare all of my security constraints and I'm going to implement my tools in a way or use SaaS tools for security scanning, I need to be able to do these things. And then you really, it almost feels like you're coming back from a first principles thing, right? I think the biggest stumbling block a lot of folks have is they want to take 10 years of infrastructure and the way we've always done things and drip and drab. And that can work, but then you ultimately end up with collisions, right? Well, we have to go touch this piece manually, but we want to declare it someday, and this piece doesn't work. And then the next thing you know, like, you're running in a pseudo hybrid environment, and that can work, but you end up really, really throttling your velocity toward just doubling down. I think about it kind of like FedRAMP, right? Any company that wants to go get FedRAMP certified, that is not a 5-week project. right? There's a whole 6 to 12 months of analysis, and then there's all the gaps you have to fill, and then there's the audit and the compliance and all of those things. It's really starting from first principles and saying, okay, we're going to take and give this a shot. You don't have to do it to your entire world, right? But take a piece of the world and say, we're going to take this piece of the world for this project, but we're going to come from a first principles and start from the beginning and say, okay, we're going to automate all of this and declare it and try it out. And then take the wins, take the gains, take the learning. I have never done this anywhere where we set out to do a thing and it worked the first time. Right? You learn a bunch of stuff along the way and you burn it down and you try again, right? Yep.
Yeah. It's software.
But you get the benefit of saying, okay, it's just software, right? So that didn't work. Let's go tear it apart.
Exactly.
And there's probably a whole nother conversation. I'd be happy to come back and have it later about, buying it versus building it and all of those things, right? But really, if you ignore everything I just said, right, the first step is not technology. Shoehorning technology into a team is the second step. Right. And hopefully it's not shoehorning at that point, but you have to build confidence and you have to build a story and you have to sell it to people because it's a change in the way you do work. And you have to take an iterative agile approach and get little wins and show the value. Otherwise, if you just come in as a hammer and say, and I'm speaking from experience here, guys, if you come in as a hammer and say, everything we're doing here is not right, like you got one or two options, right? You're either going to be super successful or you're not going to work there anymore because there's a lot of people that are going to fight you along the way.
Well, and it seems like, there are a number of tools out there today to do this. Like we had mentioned just a couple of them, whether Terraform or Ansible, Puppet, Chef, and they go back years. They all do slightly different things, which is fine because then you're going to use the most appropriate tool for the task or for that component of the task. But to your point, I think you have to take the larger view, the top-down view about what you're really trying to accomplish. And so each tool fits in, and then you can have teams that are really responsible for that part of the problem. And since it is software, we can integrate it, we can check it into repositories, we can roll it back, we can do all the things we like to do. But it will be different tools. I think, the most appropriate tool for each sort of component that you need to manage.
Just to my point when we first jumped on, right? Managing those tools is a skill set in and of itself, right? And that takes talent, right? These aren't just pull it out of the box, it just works, right? Integrating the different tools to work with each other, getting the pieces put together, right? That's a skill set in and of itself. And that's a thing that takes talent in and itself before you even start automating the things the developers are using to deliver value for customers, right? You're never going to get one tool. There's ways to do it, and you'll probably eventually get to the point where you're like, oh, this one tool doesn't do this one thing we need, so we need another tool, and we got to figure out how to plug it in. So, the tooling itself is complex and requires integration.
Yeah, there's a whole discussion that I think we need to have around platform and platform engineering versus, there was the SRE world, which was like, let me automate the operations side because our developers aren't doing enough of it, or I don't know how you really sort of differentiate even that, but there's the whole concept of platform engineering, taking this infrastructure as code concept, the state and or declarative approach to your infrastructure, applying that to your application as well, and coming up with a platform. And I think in some cases, you effectively have to build something bespoke because there are too many moving parts and there's no one clear development model. For a startup, I think you can almost always get into the point of saying, hey, look, containerize whatever application, like business logic components you have, run it in either a container as a service environment in pick your favorite cloud provider and put a front end on it and have a nice day. It's a little easier if you effectively have one application, but when you have multiple components, you have people that are building services, whether they're micro or macro, doesn't even really matter, but they're building services for others to build on top of. You suddenly have to look at the infrastructure for each of those services components, right? Everybody's going to come into this with a different language that they want to develop in. Rarely do you get one language for everybody. Suddenly you have to think about not just the infrastructure as code, but also your platform suddenly becomes another codification layer, another abstraction layer on top. And I think that's why, when people talk about current development practices, it's like we start talking about Kubernetes because that's the answer to all questions. And it's because it's a codification abstraction layer, right? I can define code, I can define state in Kubernetes to get my application pulled together, connectivity, discovery, all those things embedded in that one environment. I think where that gets interesting, of course, is when you start looking outside of that one Kubernetes bundle and say, how do I connect multiple of these things together? Anyway, there's as I always say, there's a lot to unpack here.
Yeah.
and I think
it's a continuum, right? Like,
yeah,
we set out on the industry set out to start codifying infrastructure as code, right? It is the foundational term we're using because we wanted the simplicity of code development. Yeah. But then we got to a point where there's a lot of complexity to doing that, right? Just like writing good software, right? You can write software, you can write good software, you can write bad software. It's not just writing software. And now we're kind of seeing the point where, you know, there's a lot of specialization in the ability to run these things at scale as well, right? Everything gets more complex. And so to manage the complexity, we start pulling it apart into its components. And then we say there's too many components. So we start lumping things together again. And I really do, I'm not going to say we are, but it is starting to feel like we are at the tail end of the concept of just a DevOpsian world and much more of a, you know, just empower the software developers that write the code to have to think as little as possible about the infrastructure. Whereas when infrastructure as code first started, what we were trying to do is codify infrastructure in a code-like language to empower developers to do it themselves. But now we're at a point where we just want them to write code and we want to make it as easy as possible to run the services. But that requires a set of abstractions that also require care and feeding.
That's why I think there'll always be jobs. I mean, for people who are interested in infrastructure, what they have now is a better tool to allow them to really play around with that infrastructure. It doesn't eliminate their knowledge because application developers often don't have much of an idea about what the underlying infrastructure really is made up of, or how to bring it up and how to configure it, how to monitor it, how to remediate problems. Those are the things that people with the expertise in infrastructure now just have this other great tool, which is being software-driven infrastructure for them to use.
The number of times in my career as a network engineer where I had a developer go, I don't know, it doesn't work. And that was kind of the end of the conversation, right? I still had to go figure it out. It's just a different set of tools to the same set of problems.
Yeah. Well, I think if we give developers effectively that infrastructure platform that makes their lives easier, and they can focus on, you know, containers are fantastic because they give us a bundle, you know, the developer's bundle, and it's not the, oh, well, you didn't install this library on that particular machine and that version of the all that BS effectively suddenly disappears. And we really can think about making sure that the platform is repeatable, the infrastructure services are repeatable. And we think of these things now more as services, at least that's the way I've been thinking about them for a while, right? Yes, I need network connectivity, but what do I need? I need secured network connectivity and load balancing for scale. That's my interface, right? That's the layer that I need to be able to hand to an application developer so that they just know that their application needs to scale. So don't write something where you're locking tables in an application in your database, right? You know, really start breaking those bits and pieces apart. But so in lieu of being not too long-winded here, you know, I classically say there's a lot to unpack here, which there continues to be, and we're absolutely going to have you back on, Mike, to talk more about sort of this entire system in space. But just want to say, I think we're kind of out of time for today.
Yep.
We're way over what we would normally have done. So thanks for listening to all of this. You know, certainly follow us on your favorite podcasting platform. Look us up on LinkedIn, follow us on Twitter, etc. This has been Robert Starmer. And
Tucker.
And I'm Mike Damkot.
And thanks again for listening to Cumulus on Cloud. Thank you. Thanks,
really
Mike.
good.